Hi everyone. I think we'll start now. So I'd just like to say welcome to this webinar, especially the members of the editorial team who've joined us. We're really pleased to see you here. My name's Andrew Hyde. I'm a commissioning editor at Cambridge University Press. As you've probably gathered, we're going to be recording this webinar and we're going to be encouraging people to use the Q&A function. So we want it to be as interactive as possible. And I'm here today with my colleagues, Ryan Davies and Alex Carrick from Cambridge University Press. And we're really delighted to be joined by Claire Monteleoni and the other editors of Environmental Data Science. And the reason we're here is to launch Environmental Data Science and announce that it's open for submission. And Environmental Data Science is a new open access journal that's dedicated to the use of artificial intelligence and data science to improve our understanding of the environment, including climate change. And today it's open for submissions. I'm going to introduce the journal in a bit more detail, but first of all, I just want to go through the running order. What I'm going to do is say a few words about the journal, ask my colleagues Ryan and Alex to introduce themselves. We're then going to turn to Claire to say a few words about herself. And then we have a number of kind of pre-existing questions that we're going to run through with Claire, but we're going to be checking the Q&A throughout that time to see if there are further questions from the audience, and if so, we'll turn to those and introduce those to make it, as interactive as we can. So what I'd like to do first, before handing over to my colleagues, is just bring up this. Let's just share my screen, sorry. Bring up a slide, which hopefully you can all see, which is just about environmental data science. So we've been working on this, on the case for this, I guess, for a number of months with Claire, and it's bolstered by some of our own research and conversations with people in the field. And we really felt as a result of the feedback that we got that there was a case for a new open access journal for people working using data science for the environment, who were finding it too difficult in some cases to be accepted into, whose work was being viewed as too applied for computer science journals and too methods focused for the disciplinary titles. So that was the kind of case for the journal. That's part of the rationale for the journal. And as you can see here, we've got a number of editors we're delighted have joined us, and some further editorial announcements are going to be made soon. This slide just introduces some of the data and methodological and environmental themes. So as you can see, we are taking a broad approach to defining data science and the environment, to reflect the fact that we're really only at the start of realizing the potential of these data-driven methods. And in this last slide, I'm just going to sort of outline a few key reasons why we think authors might want to submit to environmental data science. I mean, first of all, we're really pleased to be joined by the editors who've joined the board. We're going to institute a process that provides really good quality feedback to authors who submit to the journal. Of course, it's an open access journal, which is absolutely essential in an interdisciplinary area, and that's another really compelling reason that we think that people will want to submit. We will be publishing all articles with impact statements aimed at conveying the significance of the work to a wider audience. And we know that there are a number of workshops and events and conferences in this area, and so something we're really keen to stress is that we would like to offer the opportunity for those to align with environmental data science, and an initial way that can be done is by proposing a special issue or a special collection. So there's more details available online at cambridge.org.eds, and you can follow us on Twitter at ENV Data Science, and we'd be really pleased to hear from you by email as well. But I think what I'll do now is ask my colleagues Alex Carrick and Ryan Davis to quickly introduce themselves, and I will stop sharing my screen.
Okay, I can kick off. My name's Alexandra Carrick, and I'm Senior Commissioning Editor at Cambridge University Press in the Open Access team, responsible for launching open access titles in the STM space and also open access initiatives.
Hello, my name is Ryan Davis. I'm an Assistant Editor at Cambridge University Press. I work across the physical sciences portfolio, and I'm delighted to be supporting environmental data science, this new open access journal.
Great. And now can we hand over to Claire to say a few words about herself, and then we'll move into the section where my colleague Alex is going to ask Claire a few questions, and we'll check the Q&A whilst we're doing that.
We can do that during the Q&A. I also, at a certain point, wanted to give the editors a chance to introduce themselves, but Andrew, I think you need to approve Auroop and Jakob into the room, or give the permissions to Ryan to do that.
I've just added everyone as a panelist now, so hopefully everyone is able to speak.
Great. So do editor, I know this was very short notice for editors, but do editors want to introduce themselves? Just raise your physical hand or your Zoom hand if you'd like to. Okay, Julien, go ahead.
Yes, hello everyone. Yeah, I'm Julien Brajard. So I have actually two affiliations. I'm both at Sorbonne University and at Nansen Center in Bergen, Norway. So I think I'm the northernmost person here, and I'm working mainly on machine learning to improve simulation and forecast for a numerical model using mostly remote sensing data, but not exclusively. And I think there is a great opportunities here for AI in the intersection between numerical modeling, data assimilation, and data science.
Thanks. Eniko, do you want to say something?
Sure. Hello, everyone. So I'm Eniko Székely. I'm in Lausanne, in Switzerland, at the Swiss Federal Institute, in a Swiss Data Science Center. So the purpose of the center is to help bring data science into domain sciences broadly. And my work for now has been mostly on climate. So yeah, I think there are a lot of opportunities here, and the field is growing quickly. And I've been involved for quite a lot of years with the Climate Informatics Conference, and we see it growing. So yeah, looking forward to what's coming.
Thanks. Jakob, you're unmuted. Do you have, would you like to?
Yeah, great to be here. I'm Jakob Runge. I'm heading the Climate Informatics group at German Aerospace Centre. So my whole group theme is very much fitting this journal, and my interests over the past years in bridging those fields and just bringing machine learning to climate science and climate science to machine learning. So this is very much what I like to further foster. Thanks.
Right. So this is this conference that has been looking for a venue to start a journal, but environmental data science is going to be even broader. And Auroop, I don't know, I know this is on the spot. Would you like to say a few words about yourself and your research?
Sure. Can you hear me? Okay, so I'm Auroop Ganguly. My research is at the intersection of climate change and water, hydrology, and infrastructure resilience. And I do that with a variety of data science tools, from statistics to nonlinear dynamics to machine learning. I'm at Northeastern University, by the way, in civil environmental engineering. I also have an affiliation with the College of Computer Science here. And I have a joint position with the Physical and Computing Directorate at Pacific Northwest National Lab.
Thanks. So Alex, do you want to take it away with the questions? I know one of your questions is about my background and how I became interested.
Okay, I'm just unmuting, so I will pause between questions to allow a bit of discussion, so please use the Q&A function. So I'm going to start with, isn't it all environmental science based on data? Why is there a need for environmental data science?
Oh, okay. So if you enter the doc, I reordered the questions, but I'll say that the key here is data science, not data per se. So data science, we take broadly to include AI, machine learning, statistics, data mining. And the gap that this journal fills is to focus on cutting edge data science methodologies in application to environmental problems. So I think I'll also introduce myself now because I thought we were going to switch the ordering of the questions.
Sorry for.
Oh yeah, no worries. So I'm someone who has, like many of the people on the panel here on the editorial board, mostly been focusing on climate informatics. So bringing machine learning into the study of climate change. After a background in environmental science in college and then machine learning in graduate school, and then many years of just doing algorithmic machine learning and then trying to bring it full circle when I was at Columbia University. And climate informatics, which you've already heard referred to by several of the editors, is now a 10-year-old conference that is quite international and has been looking at the use of AI and machine learning in all aspects of the study of climate change. So climate science, there have also been papers on, energy, insurance, other areas that we're going to have to worry about as we adapt and try to mitigate climate change. But we had been talking at the end of a workshop, you typically, or a conference, have some panel discussion about what are the future next steps. And really what was missing was a journal. We have had archival proceedings since 2014 in our conference, but sometimes they would jump between different journals, or it would be unclear if a member of our community had a long paper where to submit to. So we're really, really excited about this opportunity, and we think it only makes sense to broaden it to other environmental challenges as well.
So at this point, I'm going to pause very slightly after each question to give people an opportunity to put questions into the Q&A. Don't know whether, can't quite see whether any are coming up at the moment. I'll pause for a little moment. If not, I'll move on to some of the next questions. Okay, I'm going to move on. Brian's prompted me to move on. So can you give us some examples about how artificial intelligence and data science are transforming our understanding of the environment? I guess it could be as part of the conference that you've set up or in other research that you've seen recently.
Well, for this, I want to turn again to the panelists so we can hear different examples. Maybe each person can tell us about their favorite result that could either be their own or somebody else's, or both. I think Julien had something to say.
Yeah, it's not like I have a favorite result, but there is one domain I think which is very promising. So it's for forecasting. So for some, let's say 20 years now, it's very usual to combine numerical models and observations to improve the forecast. For example, the weather forecast, but also ocean state forecasts, and a bit more recently, I would say few years, we also able to have some seasonal forecast, decadal forecast, and it's become more and more difficult to improve those forecasts because we reach limit in model resolution. We also reach limits in how good we can improve the models in terms of the model errors and the uncertainty of these errors. And since for 2 years now, machine learning has become a very serious candidate to improve, to be a game changer is in improving those forecasts, especially at the decadal and even seasonal scale. And so far, there is no, it has not been used operationally, I think, but it's starting. It starts to be used in a lot of results, and I think it would be great if environmental data science welcome include the new results about how machine learning can use the data in a more complete way to really improve the model, and not only as it has been done in the late decades, or not only the initial state of the forecast, but also the model itself. So this is a quite exciting, I think, road for data science.
Yeah, great. Maybe to
jump else like to chip in?
Yeah. My perspective is from statistical and causal inference, which is a technique to learn causal relations from data. And I've been over the past years, working on this in the field of climate science, where in the past decades, mostly methods from correlation or regression analysis were used, and where such methods are now being picked up because it's quite suitable, many of the methods from causal inference, for research questions in climate science, like what drives what. And this also applies to many problems that are being addressed in general in climate science. For example, you can see analogs between, say, video prediction and climate models being, or the observations from satellites being basically an image over time. And so many techniques from deep learning are having potential to be applied in this realm. And that's a very heavily investigated current research. So there's many ways in which kind of the machine learning revolution comes to climate and generally environmental sciences. And it's very exciting.
I can jump in, or Auroop or Eniko, do you have an example that you like?
Sure, I can. So couple of examples that I've seen recently, which have really been very exciting for me in terms of where they could go. And one is in what are called climate oscillations, so El Nino. And there was a recent paper in Nature where they talked about, deep learning improving El Nino predictions over, interannual time scale, or of that order. And it's easy to underestimate the importance of El Nino. It's just, one oscillator among many, but it's one of the most important things that we don't understand as well as we would like to, and that impacts, hydrologic cycles and regional weather patterns across the globe. So that's one very exciting kind of thing that, these things, some people have said that these are potentially chaotic, have, strange attractors. Some people wouldn't agree. Whatever you say, these are hard, and the ability to improve those. So that's one thing. The other kind of development that has been happening also relates to something that has been a very hard problem in weather, climate science, etc. So this is cloud physics and cloud parameterizations. And there are some emerging work now which seems to suggest that maybe, just maybe, machine learning could do something about it. Of course, one thing to be a bit careful here, as all of us are saying, and as Jakob said about causal reasoning, causal modeling, is that in these kind of areas is just not enough to say that I have improved prediction. And I was reading this interesting article published earlier this year in, I think it was in PNAS, Proceedings of National Academy of Sciences of the US, where they're talking about the unreasonable effectiveness of deep learning. And that may work for certain kinds of problems fairly well. So if it does machine translation well, unreasonable or not, I'll use it. But it'll probably not work so well for most kind of environmental problems if it is so unreasonable that I don't understand it. So there are challenges in that space. So interesting developments, but also some things to do.
Cool. Do you have one, Eniko?
Sure. But I think the others have well summarized the things I wanted to say. Maybe I can just go over them quickly. So from my personal work, I've looked at dynamical systems and the climate. I like to see the climate, for example, as a dynamical system, and then we can bring everything that is in applied math. There are many methods that are there available, and we can try to see how they work on real data, which is not really straightforward. Causal reasoning, it's also working with causal methods. It's quite challenging, given in toy examples. So moving to real world data, it's again a real challenge. I think and one thing, for example, in climate science is that there is a strong inertia towards probably more linear methods. And in machine learning and math, there are so many non-linear techniques that are developed. And I think there is a lot of room to try to bring slowly those things to more applied settings. And as Auroop said, I think for me, I've never worked on that, but machine learning based parameterizations, because we know that with the new release of the climate models, the CMIP 6, one of the most uncertain thing is how can we model the clouds? So is there a chance that machine learning or deep learning can help here? And there is a lot of work in machine learning now from the other side, where they try to understand the inner workings of the neural network. So this can also, we can back propagate and see why are the predictions working better. So I think there is a lot of work bringing them closer together.
Thanks, everyone. Yeah, so one thing that is sort of interesting is that in AI, we often look at ensembles, and this is a pretty general abstraction. But you'll see if you go to some of the top machine learning competitions and AI competitions that some sort of ensembled technique, which uses a bunch of different algorithms, will usually be the winner of these competitions. And what's been amazing to me is actually throughout the field of environment and environmental resilience, seeing where ensembles come in. So I started working on them just algorithmically, where in AI, the example we would use is that you want to manage your money or your portfolio on the stock market, right? A financial application. But then it became really clear that these could also, these algorithms to take the best advice from an ensemble of predictors were also really helpful for combining the predictions of climate models. Now, this could also be used for numerical weather models, or even from a single climate model when you don't know what the parameter value should be for some very sensitive process in the environment. Maybe you could run it using different values of that parameter, perturbed physics types ensembles. But recently, as I've branched out here in Boulder to work on all these environmental resilience topics, such as wildfire tracking and monitoring, so clean energy forecasting so that it can be better put into the grid, water management such as reservoir management, which deals both with hydropower and also is important for drought conditions that then can affect wildfire. I don't want to use the word cause. Is that these ensembles are popping up everywhere. So it could be that a generative model is being fit, and then samples from it are used as an ensemble for some application. Sometimes you actually do have numerical weather predictions that you're using as input, say, to forecast how much solar energy is going to be output in the next few minutes, or also with wind. And so that is one area that I think machine learning has a lot to offer. The other thing, and those of you that have seen me give talks recently that I'm really excited about, is around the power of deep unsupervised learning, and what learning these latent spaces can help us in terms of interpretability in a variety of environmental fields. So, you know, I think we may have gotten a little technical. One thing I wanted to call out about the journal, which I think is really nice, is that authors are going to provide impact statements, which are going to be short, publicly understandable and digestible statements, so that we can make this understandable to a broader audience of stakeholders. So let's see, it does not look like we have
Doesn't look like we have any questions in the chat. So that was a great set of answers around machine learning and artificial intelligence. So I'm going to ask the next question, which is around what you find exciting about the new Environmental Data Science Journal, what inspired you to join. So that's first to Claire, and then also to the other editors on the call.
Nice. Well, as I said, we had actually been sort of saying for years that we should start a journal, and this is among the Climate Informatic Conference folks. Cambridge University Press literally knocked on my door. This was in the before times when I was working in an office with a door that was not in my home. It was on campus, and one of your senior associates was, I guess, at a math conference in Denver. And apparently there were a lot of emails in my inbox, but my inbox has been perennially a mess in the past few years. So the door knock definitely helped. And then it was very exciting to think that we could now have a home in a respected journal, you know, associated with a historically very esteemed university, for progress on AI and data science for these major environmental challenges that society is facing, including climate change and also more broadly. And that all these authors in this community we had been building would now have a place to submit their work. And also, now that more and more conferences and workshops are being spawned in different parts of this space, that we could actually provide a place to publish their peer-reviewed conference and workshop proceedings. So it really opened things up, and I was really excited to bring together an inaugural set of editors to have sort of a broad view of how we could define this.
Shall I move on to Auroop? Would you like to say why you are excited or inspired to join the journal?
Sure. So this definitely is a passion of mine in a variety of ways. So I was very excited when Claire contacted me about this. A couple of things here. So a lot of the interesting research or interesting findings that are happening these days happens to be at the intersection of traditional disciplines. Something is happening. It's either those disciplinary boundaries are not good enough, or they're dissipating, or maybe whatever boundaries were defined, I don't know, 16th, 17th, 18th centuries are not good enough for this century. But going from the philosophical to the specific here, so in data science, we have separate conferences or journals for statistics versus econometrics versus machine learning. And even if you look at data science, broadly speaking, within computer science, then there are various kinds of data science conferences and so on and so forth. And that's fine. There may be a good reason for being. However, when we look at those from environmental perspective, we need any of those that can solve environmental problems and give us new insights. And the other thing is give us impact. So we talked a lot, many of us talked about, climate science challenges, whether it's cloud physics, whether it's El Nino, but there's also this challenge of translating this to adaptation, and we need to do that more and more, and to mitigation, whether it's in the context of power grid, whether it's in the context of, as Claire was saying, water. So all of these things, we have to bring it together. Similarly, in environmental, though, it's sort of similar. There is climate, there is meteorology, there is this, there is that. And again, there is a need for cross-learning within this particular slice and dice that has been picked up here, which is data science in all its flavors, environmental, it's on it in all its flavors, and what can this community learn from each other, and in so doing, get new insights, advance the science and the methods. So it's very exciting for me.
Thank you. I'll move on to Jakob next, if you'd like to.
Yeah, thanks. So I think I can really echo this, because what we have up until now is that if you publish in a machine learning conference, then you might put some exciting application in the last page, because it's not really valued as much as it would maybe deserve. And on the other hand, in climate science, if you write too much math in a paper, the review process might either they don't understand it and say it's too technical, that's rejected, or you put all the interesting stuff that you think is interesting to the method section, like in nature journals or so. And having a journal that interweaves these, that puts interesting applications together with interesting methods, is something that is what I really look for to publish myself. So yeah, thanks a lot for bringing this.
So coming to Julien and Eniko.
Go ahead, Julien.
Okay, thanks. But I don't have much to add, because I acknowledge everything what was said just before. It's very nice. I think when we saw that climate informatics community was growing more and more, and we see there is a need to have this place where we can, as it has already been said, but have both focus on both the application and the method, and so yeah, the conference was there, the community was there, but so now I think it's a natural step, and I'm very excited that there is a journal now that also is part of this trend. So yeah.
Yeah, so I fully agree with all of these things. Maybe just a very practical thing in the last few years, and now we'll talk about this climate because that's what we worked with in the last few years. But since we started to want to have proceedings, we had a strong debate, because people in domain scientists, and this is climate environment, they are used to publish in journals. People in machine learning, they are used to publish in conferences. And it was extremely difficult for the community to choose a common way of publishing the short papers that they were submitting, because they didn't want them, maybe people from domain science, they didn't want them in the proceedings because they are used to submit to journals. But that was okay for machine learning people, but then it was dividing the community. So we had long discussions every year what to do, and there was really a need of something that can like make both sides happy in a way.
Some really great answers about the journal. We've talked a little bit about why authors might find it attractive. How do you think? Why do you think new authors will publish in this new venue? For example, Claire, I'll turn to you first.
Oh, well, I can talk to who are the authors that we're going to target first, which is certainly people from the Climate Informatics Conference, but also all these other relevant workshops and sessions that are just proliferating. I'll be announcing this and referring to today's launch tomorrow at the Climate Change AI workshop. I'll be also popping into a panel at AGU next week that's relevant So we want to get the word out, of course, to everyone at these events, which all happen to happen, in December, but throughout these communities, because as Eniko and other people have pointed out, we're looking for a place where we can get recognized both for our methods, contributions, and for their impact on environmental challenges. And then the other opportunity to highlight is that organizers of such events are welcomed to then contact us about doing a special collection for their conference proceedings or workshop proceedings. And so that's kind of win-win, because these are peer-reviewed articles that would now be published in this new journal, EDS. Yeah.
Any of the other editors want to add anything about authors and who they are? Julien, Eniko, Jakob, Auroop?
No, I can echo that. It's really something. Every conference we've looked for a nice and somewhat prestigious way to publish the proceedings, rather than putting them on the NCAR website, which we did previously. And this has always been an issue to find a good venue and negotiate. And Julia can talk about this more for last year. So this is really something that we, for this reason, like.
Yeah, and from the other side also, I think one of you are already saying that. I think it was either Jakob or Julien, is that on the domain side, if you will, there are several groups who want to publish some of their, what they think are their best papers, which have innovations in methods and innovation in environmental insights or advancing the science, but somehow you have to push those. Either in the appendix or in the online supplement, and that's doing a disservice to the overall advance that is being made in certain kinds of papers, not all kinds of papers, but certain kinds of papers. So this could be a great venue for that.
Maybe to add, it also helps that this this type of journal with the audience being interdisciplinary poses a challenge or a demand on the authors to write in a way that is accessible to both of these audiences, and this is very nice. It will require, and we as editors will have to make sure that this is the case.
And actually, just stepping back, this is an experiment or an example of building a new field. To Auroop's point, not all fields that were invented a long time ago are going to cover what is needed for this future that we're getting into. And so new fields need to come along. And the field of environmental data science, many of us are already training students in this field. And if you're a researcher who's not purely a machine learner and not purely an environmental scientist or not purely in one of the relevant domains, you're part of that new generation. It could be climate informatics, it could be environmental data science, it could be specifically AI for climate change, or one of a variety of things. We also have an editor focusing more on ecology, an editor focusing more on biodiversity, an editor focusing more on air quality and related challenges, and hope to broaden our scope. The people that will be publishing it are really this next generation that are getting trained at the interface. And we're seeing many universities start to offer interdisciplinary degree programs. And so these people that are now researchers in this new domain, we want to give them an opportunity of a journal they can publish in.
Were there any additional comments to this point? If not, I'll move on. We've talked about the title specifically, and we've talked about the community and who the authors are. So Claire, what do you think open access and open research will bring to this new venue and new journal?
Well, the environment affects all of us in society, and it also, affects vulnerable communities more in various countries or regions when there's issues of social justice and environmental justice. And so accessibility of research, especially the newest research, is extremely important. So to the extent that the current technology that we have will allow us, we are embracing the principles of open research, and we're going to continue to look for ways to direct the journal more into a more and more open direction. So some examples, we're encouraging the sharing of code and data. This will increase reproducibility and transparency. And this is impactful not just in the environmental fields where it's so obvious. We see that you know, people want to see all the sources and the reproducibility of conclusions made in the environmental field. This actually touches right now to the core of AI itself, around AI ethics, reproducibility, transparency, and accessibility. So we hope that these values that we're embracing will help advance both fields.
So I'm going to open this up to other editors on the call. Would you like to add anything about open access, open research, which you find particularly important, and that this will help, the journal will help by being open access, this will help authors or reviewers or readers with?
I can say I personally am very much in favor of open access. The whole center where I'm working, it's now 60 people. That's one of the main goals, is that things should be open access. I've seen even during panels at conferences or workshops, people in the audience saying, I'm not necessarily a researcher in this field, but I'm interested and I don't want to pay 30 or how much I'm not able to access what the work you're doing, and it's people who are interested. I think the code is extremely important, and that's been for a few years now in machine learning conferences. That's starting to be like a real demand, and I think I'm seeing also a little bit people in domain sciences, they are starting to publish, I don't know, maybe code on GitHub, and then there is some data on Zalando. So there is a little bit this trend that it's not an easy one. It's not easy to have all of these things there, but more people do it, I think more it will gain track.
So you mentioned a little bit about the data, but also use of things like Jupyter notebooks, whether any of you wanted to emphasize that part of open research and open access as well. Speak about its importance.
Well, so for example, with the hackathons that we've been running with climate informatics conferences, and that also we want to run more broadly in various environmental topics here at CU, for example, we make what's called a starting kit. So it's a Jupyter notebook that first really gives very accessible high-level background to the problem, because we're not going to assume that a machine learning student has had any exposure to problems in the environmental domain. Ways to visualize the data, ways to play around with it, pre-implemented methods. And so those sorts of things can be serve as educational tools. You know, more generally, if somebody is using a Jupyter notebook in their research and they're willing to share it, then that would give us a reproducible pipeline. But even if they're not, you know, we encourage them to share their code.
Okay, so I'd just like to thank everyone for joining. I think, you know, we probably worked through all of the questions that were part of our agenda. So really appreciative of everyone spending their time to talk to us today, and I hope you're okay with us using the recording of this conversation, because we'll make that that available with your permission to let people know about this new venue. And thanks once again, and it was really great to see you all.
Thank you.
Thank you.
Lovely to meet you all.
Yeah, thanks.
Thanks.
Thank you.